Good to go, get started off. And of course, the recording is in progress and we are live in the studio. Assalamu alaikum, everybody, for all those who joined in later on. Welcome to the third demo class of our CS demo class series. I am Sir Maaz Munir and welcome to our class once again. Okay, and of course, today is going to be the last demo class of this session. Inshallah, after this, we're going to have the classes only for the students who end up registering with us. So I'm just going to write the number for our TA. You may just text Miss Naiba. She's going to add you, inshallah, into the group. For the registered students, that's the number up here, 318-177-2015. If you've already reached out to her, don't worry. Her DMs are at this point literally spammed up. So she's going to reply pretty quick, inshallah. But if she doesn't, don't hesitate from dropping a reminder, okay? So we have a question, sir. How will you mark the test? And I don't know because an internet face-to-face is different. How will I be marking the test? So basically, you'll be given a set of questions. You need to honestly solve it on your own. You're going to take the picture, send it to us, and we're going to create a marking scheme using which we're going to mark it up, and we're going to provide you a detailed feedback on where you lost the marks, where you gained the marks, why did you lose the marks, why did you gain the mark, and of course, alongside a final score that, okay, you scored out of 15, let's say 5, 6, 10, 14, and so on. So it's pretty much reliable given that you are given also planning to give it your best. So I'm telling you all again, at the end, if you don't want to give it your best and aap khud hi cheating kar rahe ho, to it won't work, right? But if you want to do it your best on your own, you give it your best at your end, everything would be inshallah ensured ki hamari taraf se best ho. So welcome officially to the third demo class of our CS classes. Just to give a quick recap of what we were studying, we yesterday saw that our computers are basically made up of switches, right? We saw that a computer is nothing else than a switch or a circuit which could either be on and off. We saw that an on could be represented as 1 and an off could be represented as 0. And because our computers can only understand a 1 or a 0, this came up to be the language of computers, which we today call as binary. Then we saw that, okay, there are different ways of displaying the numbers on a computer, which we call as the number system, in which we have binary, which is basically base 2. Why is it base 2? Because it has only 2 possible values. Then we have denary, which is basically the conventional number system, which is base 10. Why is it base 10? Because it can have 10 different values. What 10 different values? 0, 1, 2, 3, all the way till 9. And then we saw how I can convert a denary number into binary number. So we saw that whenever I want to convert a value into binary, we understood that every specific slot or a position where I could put a value of 1 or a 0, it has a specific value. And so I need to basically put 1 under all those slots, which when I add them up, gives me the denary number, which I'm trying to convert into binary. So we did a few examples last night, and I'm going to continue from the same point by doing 1 or 2 more examples today before moving on. For example, let's try to do a question which converts the number 93 into binary. So if I have to convert 93 into binary, the first thing is that the way I mentioned that date yesterday too, if we basically in exam, most of the cases be given a slot like this. Okay, so in exam, the question would be making something like this, a box. And that box will be basically having 8 different sections. 1, 2, 3, 4, 5, 6, 7, and 8. And guess what? These 8 are the exact same blocks which were being denoted yesterday by these slabs. So like this is position number 0. This is position number 1, position number 2, position number 3, position number 4, position 5, position 6, position 7. And if I have to write the equivalent value of it, I know we calculated this yesterday using this equation that value equals to base raised to power position. So like the first one is going to be, because it's binary, binary is base 2. So 2 raised to power 0 is 1. 2 raised to power 1 is 2. 2 raised to power 2 is 4. And so on, 8, then 16, then 32, then 64, and then 128. Now, in most of the cases, when dealing with O-level and IGCSE course, you would be on max be required to deal with such numbers. There are a few exceptions, but that is something which we are going to discuss when we go to the questions, right? And now, this point, I want you all to understand the concepts behind how something is happening and why something is happening that way. Now, if I have to convert this 93 into binary, the point here to understand is that if I have to write a denary number in terms of binary, because I know what's the value at each position, when I put 1 under a specific position, like in this box, I put a 1, this means that, okay, I got 32. Then if I put 1 up here, this means I got 8. So if I add them up, this makes it a 40. So like this 1 up here with all the other being 0, like 0 means off. I'm only going to be putting the importance to the places where I put a 1. If there is a place which has 1, this means, okay, this is important for me. If there is something which has the value 0, I don't need it, okay? So 0 equals to ignoring. 1 equals to important. Why 1 equals to important? Because 1 means that the circuit is on. So similarly, we saw this yesterday too, that if I have to convert a specific denary number into binary number, the way we do is that in this set of whole boxes, we're going to put 1 under all those values, which when I add them up, I should be getting the number 93. Now, the best way to doing it is, then I'm going to see from the most left-hand side. And I'm going to see, okay, should I put a 1 up here? No, right? Why should I put a 1 up here? 128 is greater than 93. So if I put a 1 up here, that would mean that, okay, I'm trying to get something greater than 1 or equal to 128. I mean, the 93 chahiye, so I cannot put 1 below this, right? Because I cannot say something like 128 plus something makes a 93, given that we don't have negative numbers. That's not possible. So 128 wala to 0 makes sense. Then 64, of course, 64 is going to be 1. Now I'm going to use my brain and I'm going to say, okay, 64 plus what thing is going to give me 93? So you need to use your brain a bit by subtracting the two values. So you have to subtract 93 and 64. Remember, in your basic computer science exam, you need to have the basic mathematical skills in your mind. Okay, so if I now subtract these two numbers, I can clearly see that the answer is going to be what? 3. Okay, that's going to make it 8, and this is going to be 13. So 13 minus 4 is 9. Okay, and then 8 minus 6 is 2. So I get my answer to be as 29. So now I'm going to put 1 under all those places so that I get a 29. For example, 32 to 0 ho jayega. 16 plus 8 is what? 16 plus 8 is 24. 24 plus 4 is what? 28. 28 plus 1 is what? 29. So you see, I sort of got the exact binary value out of it. And now if I add all these digits, which I basically put a 1 under, like this, and this, I see that my answer is 64 plus 16 plus 8 plus 4 plus 1. Let's convert it. So 16 plus 4 is a 20, right? This is just a technique. You add the values which are easy to add, okay? And then, okay, so 16 plus 4 is 20. 20 plus 64 is what? 84. Kuch miss to nahi ho gaya. 64 plus 16. So 64 plus 20 is what? It's 84. And 84 plus 8 plus 1, if I also highlight this part, is basically a 9. So now if I add 84 and 9, I get the answer to be as 93, which is exactly same as the one which I wanted to convert at the first place. So if a question comes up asking me to convert the 93 number into binary, this is my final answer. So to represent 93 in binary, my answer is going to be 0, 1, 0, 1, 1, 1, 1, 1, 1, 0, and 1. And that's how you write 93 in terms of binary. Okay, now if anybody, I see that we have a few extra students today. So if any student missed out yesterday's class, I would recommend that you go onto my YouTube channel. Perhaps I even shared the link in the group. Perhaps मैं यहाँ पे फिर भी भेज देता हूँ. Go and re-watch the demo class for yesterday, because this was something we studied last night. So you will not understand it until or unless you take yesterday's class. So I'm going to reshare it with you all in the chat box too. You may just open that up and watch that recording, and then you're going to fully understand what we are trying to do up here. But this was just a quick recap of what we did last time. Okay, how you go from a denary number system, like something conventional number system, into binary. This was pretty much very basic content, and this was something I know a lot of you would be good to go with. But right now we're going to be basically learning, or perhaps before even learning then we can do a few practice questions. Right now we're going to be doing an exam style, what do we call it, a different concept, after which we're going to jump into a bit of exam style questions, so that aapko pata lag jaye ki okay, exam mein question kaisa aayega or how will I be solving it. Now we saw how I can go from denary to binary. We saw this method. But right now we're going to be learning how, if somehow the question gives me a binary value and they expect me to go towards the denary number, how will I do that? For example, a question comes up saying that, okay, there's a number in a specific memory slot. Okay, so in your computers, we all know, right, there is something known as memory. And a memory is a place where basically data is stored. Now, within the memory, the part where your binary values are stored, these containers which I'm making, where you see all these values are being stored, perhaps let me just copy up the same exact thingy from up here. So let me just duplicate this, bring it up here. So this specific container type of thingy, which you see right now in front of you, that is basically storing these different zeros and ones value. This thing is basically called as a register. So a register is, it's not your notebook register, just where you are making your notes and all. It's basically something used by the computer to store the values of binary. Okay, so this thingy, this whole structure, or this, you can say, oh my bad, I was trying to draw a shape. Yeah, so register. So this thingy, which basically allows you to store binary values, just the same way in my home, I might have a shelf, right? We have shelves in home, right? In one shelf, you might put your books. In the second one, you might put your toys. In the third one, you might put your games and whatsoever. Similarly, your computer, the memory is a very big thing, right? So like if I say hard disk, a hard disk is a very big thing. In your hard disk, that small portion which stores the binary values, that small thingy, like मैं बोलूं कि okay, आपके घर में अलमारी तो बहुत बड़ी है, okay, you have a very big cupboard, but among that cupboard you have a small places where you can sort of have boxes being put up for different type of games. अब वो एक box जब collectively 3-4 boxes इकट्ठे किए जाते, that is what we call as a register. And this register is basically a memory slot that stores binary values. So I can even write it up here for you guys if you want to look onto the notes later on. A memory slot storing binary values. Storing binary values. So if in exam a question states that okay, a register has this value, so it's pretty much evident at this point, okay, that it's going to store what type of values? It's going to store binary values. So now, for example, a question comes up and they give you sort of a binary number, something like let's bring this below, or perhaps yahan pe rehne do. So if a question comes up that you need to convert this binary number 001010111 1 2 3 4 5 6 7, yeah, and they ask you to convert this into denary, how will I do that? So at this point, I'm not going to be introducing any sort of, complex method or something which is going to confuse you. Now, I'm not that type of teacher. What I'm going to do is I'm going to teach you one method which literally works for all those places. So we just recently saw that if a denary number is given to me and I want to convert it into binary, what do? I put ones under all those places, jiski value when I add them later on, I get the same denary number at the end. Now, this scenario is pretty much very similar to what we were just having beforehand. How? For example, if a binary number is given to me, you know what I'm going to do? I'm just going to be putting ones under, like I'm just going to copy this binary number up here. For example, this is 0, 0, 1, 0, 1, 0, 1, 1. And because I already know the values for each of the positions in the register, I know that the first box has the value 1, the second has the value 2, the third has the value 4, and so on. I'm going to be basically adding all those values for under which we have the value 1. So we have a 1 up here. We don't have a 1, so ignore this. 1 up here, then ignore 1 up here. And then, of course, the other two are 0, so I'm going to ignore. So the denary answer for this specific part comes out to be as what? The value for this is what? 32 plus. The value for this position is what? 8. This comes out to be as 8. The value for this position is what? It's 2. The value for this position is what? It's 1. So if I add them all up, I get my final answer to be as what? I get it to be as 32 plus 8 is 40. 40 plus 2 is 42. And 42 plus 1 is a 43. Hence, this binary up here is basically representing 43. So this is a very easy method of converting from binary to denary. And to be honest, what we are identically doing is we understood that, okay, we have a register and a register have different positions. Now we may call it a position, we may call it a box, whatever you want it, call it. But every position or every box has a specific value. Similar to saying that, okay, if I have 1,256 written up, this is ones, this is tens, this is hundreds, and this is thousands. Similarly, if I have to write a binary value, every single digit up there has a different value associated with it. And that value is this, coming from the position and the base value. So we saw this yesterday कि ये कैसे है, and I also gave you a quick recap. Now, if a question asks you to convert a denary number into binary, what I'm going to do, I'm going to basically put 1 under all those places, which when I add them up, I'm going to get that denary number. And when I'm given a binary number and I'm asked to convert that into denary, what I'm going to do is I'm going to put this binary number in this specific register place, and I know the value. So wherever I have the value 1, I'm just going to add the values of those places, and I'm going to be getting the final denary number. Now, just doing these questions won't make sense, right? For that reason, I brought up these 2 exam level questions for you all. These are directly from your Cambridge examinations. And you can see in your exams, they will literally be asking you on such simple questions. So I'm going to solve this with you easily to see how we're going to get the answer. So the question says, 3 denary numbers are entered into a computer. The computer converts the numbers and stores them as binary. Give the binary number that would be stored for each of the denary numbers. So these are 3 denary numbers. They gave us a working space, and they expect us to convert it into binary. So how do I do that? Pretty much easy. I'm just going to copy this thing up. Whenever I get any question on this in exam, I'm always sort of going to create this one box, right? So I'm going to copy this thing, and I'm going to copy it thrice because we have 3 values for your ease so that you don't get confused. Okay, so we're going to have these 3 of them. One of them used for all of for the specific number of the value. So this is 10. So we're going to do the 10 one calculation up here. How will I find 10 up here? So if I have to find the binary for 10, this means that I'm going to put 1 under all those places, which when I add them up, I should be getting the answer as 10. So should I put a 1 up here? No, right? Because 128 is way larger than 10. So you can keep this as a rule of thumb that if a value is greater than what we are trying to find, to answer ho hi nahi sakta. That's not even possible to be an answer. Okay, so we're going to just ignore that. So this comes out to be a 0. 64 again greater 0. 32 nah greater. 16 greater. 8 yes 8 could be. So 8 comes out to be as 1. And then what will I add into 8 so that my final answer is a 10? It's 2. 8 plus 2 is 10, right? So I'm just going to put 1 under the 2 slab because when I add 8 and 2, I get the answer to be as 10, which means all the other places are to be ignored. So whenever I have to ignore something, I'm going to put a value 0 there. So this comes out to be as my first binary, where in my answer section, I'm just going to write this part. I'm going to be like, okay, 0, 0, 0, 0, 1, 0, 1, 0. Perfect. Okay, then the second one is basically a 50. So if I have to do it for the 51, same logic again. 128 greater, so that's going to be a 0. 64 is greater, again 0. 32 is perfectly fine. Now, if I have to add something into 32, what it would be? It's going to be 32 plus 18, which is going to get me a 50, right? So now I'm going to put 1 so that I get 18. So 16, of course. And then what will I add into 16 so that I get an 18? It's going to be 2. So I'm going to put a 1 up here. So all the other places again are to be ignored. So if I have to ignore them, I'm going to put a 0 there. So if I add these values, 32 plus 16 is a 48. 48 plus 2 is 50. So the second answer comes out to be as 00 11 00 10. And that's my second answer. Likewise, if I now look on to the third one, which is 201, 201, definitely 128 is pretty much smaller than that. That's going to be 1. So now in questions like this, I would advise try to use your brain by subtracting the values. That's going to simplify the whole process. So let's try to subtract this. 1 minus 8 can not go. 0 cannot go. So we're going to make a carry from here up here. We're going to get 1 up here. Okay. Then of course I need a carry there. So this is going to become 9 and this is going to become 1. So this is now going to be 11. 11 minus 8 is 3. Right? 9, 10, 11. Yeah. 9 minus 2 is 7. 1 minus 1 is 0. So the difference is of 73. So now I need to put 1 under all those places so that I get the answer to be a 73. Let's see. 64, of course, perfectly fine. Because 64 plus what will get me a 73 now? 64 plus 9 will get me a 73, right? So if I have to do it that way, now I need to just do 9. 9 kahan se aayega? So I might get a 9 by doing 8 plus 1. That's a 9. So if I add these values, 128 plus 64. So what is 128 plus 64? That's pretty much easy. It's 192. Okay, so it's 192. 192 plus 8 is what? It's 200. 200 plus 1 is what? It's 201. So I got my answer, right? I got my answer. But now you might be wondering, sir, what I have to do in these empty slots? So whatever are empty are to be ignored. And whenever a computer wants to ignore something, we put a 0 there. So for that reason, all these empty slots are going to be filled up with 0, 0, 0, 0. Therefore, my answer for the third part is going to be 1, 1, 0, 0, 1, 0, 0, 1. Doing this will basically get you a perfect 3 by 3 in your exam. Similarly, you might also get a question on the other end saying that computer stores data as binary and that the binary number 1010111110 is to be stored. And you are asked to convert the number into denary. So how will you do that? Remember the same exact thing which I shared with you, this diagram. Okay, this is the most important diagram for your topic number 1. It's literally that one thing which is going to get you your answer. So now, if I have this register with me alongside the values, I'm just going to put the binary number inside it. So this is going to be 1, 0, 1, 0, 1, 1, 1, and 0. So now I'm going to add all those places which has a 1 below it. So this, 0 ignored, this, and of course this. Let's add them up. So I'm going to basically add 128 plus 32 plus 8 plus 4 and plus 2. So 128 plus 32 is what? It's going to be 130. 130 plus 30 is 160. Then 8 plus 2 is 10 plus 4. So that gives me my answer to be as 160 plus 10, 170, and 170 plus 4 as 174. And that's your answer. So we just got our answer in terms of denary. So that's how you basically convert the conventional numbering, which we generally have in our day-to-day life, which we call as denary, into binary. And of course, at the same time, if a binary number is given to you and you're asked to convert it into denary, this is how you convert it into denary. Now I'm going to be opening the chat box, and I only want you all, if you have any questions, to mujhse bata do so that I can answer those questions. If not, then we can move ahead towards the next topic. So the chat box is open, and all the questions regarding the difficulties should be asked up here. Okay, so any questions? Clear, that's great to know. Sir, is the base 10 and conventional number system the same? Yes. So base 10 and conventional number system तो मैंने आपकी आसानी के लिए इसको बोल दिया ना, so that you understand कि ये conventional number system है. But generally it's basically denary number system. इसको computer science में हम denary बोलते हैं. Sir, will calculators be allowed? No, not allowed. Can we not go above 120? We can, but that's something which we're going to discuss afterwards. Okay, when we get to a bit of complex questions. Not necessarily, Abdullah. Once we get to that discussion, आपको समझ आ जाएगी. तो समझ आ जाएगी. We're going to come to that later on. Okay, easy scene. All right, perfect. Okay, that's great. 18. So 1, 2, 4, 8. No, Maham, that's not going to be 18. Kar lete, 18 ka kar lete. Can we make this table in exam? Of course you can. Sir, from when will the proper classes started? So inshallah, today was the last demo class. Inshallah, from the 8th of June, like we're going to have 3 more days to have the demo classes for the other C subjects, which are maths, English, biology, physics. You can take those demo classes. And inshallah, then from the next Monday, we're going to be having official live classes being started. Okay. So Maham is saying 18 ka kar le. So if I have to do it for 18, it's pretty much very easy. I'm just going to make the same diagram, this same thingy, and now I'm just going to put 1 under those places that gets me an 18. So for an 18, it's going to be what? 16 plus 2. So 16 plus 2 gets me the answer as 18, which means all the other places are to be ignored. And if I have to ignore them, I'm going to put a 0. So if I have to write the value 18 in binary, my answer is going to be 0, 0, 0, 1, 0, 0, 1, 0. That's the answer. Maham, you tell me in the chat box. I'm opening it again. Is this clear how we got the 18 now? What you did at the first place was for 9. It wasn't 18. So you need to be ensuring that you always, yeah, exactly. I get it. Okay. Perfect. Hi. Okay. So there is also the log method for denary to binary conversion. There are a lot of methods, Ibrahim. There are a lot of methods. I'm going to be sharing the method which is the most easiest and the one which has the least chances of you making an error. What resources will be provided? So a lot of resources will be provided. You may watch the first demo class. उसके अंदर हमने detail में discuss कर लिया था कि upon registering what resources would be provided. So you can just watch that. उसके अंदर I've shared everything in great detail. Okay, perfect. So now we have understood two things. We saw that okay, there is a number system with the name of binary, and then there is a number system with the name of denary. You go from binary to denary, and at the same time you go from denary to binary, which is perfectly fine. But you know what? Computer scientists were like, okay, there's a problem. The problem was that when I was sort of using computers, हमने तो देखा that just to store the value 18, we sort of have such a long binary number. Now, if I ask you to do like a sort of an Einstein level calculation, which has sort of mathematical complex calculations, bro, to represent that in binary, it would have been literally like thousands of such numbers, right? Thousands and billions, and I don't know how long of those numbers. So what computer scientists did was, they were like, let's introduce a third number system. So they came up with something known as hexadecimal. Hexadecimal, which is basically the third type of number system. So till now, we have studied two number systems. The first was binary, the second was denary. And right now, we will be going into the third number system, which is known as hexadecimal number system. So number 3 comes out to be as hexadecimal. And just the way we saw for the previous two, we saw that binary is base 2 number system. We saw denary is base 10 number system. Similarly, hexadecimal is basically base 16 number system. And if I say that it's base 16 number system, this basically means that it is basically created using 16 different values. Now, the question in your mind would be, sir, what are those 16 different values? I get it. Binary के लिए तो 0 and 1 थी. Denary के लिए it was 0 से 9 तक. But after that, what are other digits? Because we don't have any other numbers, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, सारे तो cover हो गए. अब ये 16 कहाँ से आएंगे? Now your hexadecimal number system is sort of a unique number system. You know why? Because it was something which included both the numbers, and the computer scientists were like, okay, let's also add a few letters inside it. So it's a combination of letters and numbers. And what are those letters and numbers? So hexadecimal, for its first 10 values, is from 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. 100% similar to that of denary, like bilkul same to same cheese. But after 10, because you cannot represent 10 as a single digit, like 10 single digit, no, right? 10 is not a single digit. 10 is the combination of this 1 and this 0. So if I ask you एक position के अंदर where either 1 can come up or I say a 0 can come up, is there a possibility that at that same point you try to fit a 10? No, that's not possible. So because computer scientists were like, okay, we need to come up with 16 different values, and they could not bring up something like 10, 11, 12, 13. Why could they not bring this up? Because 10 is basically 1 and 0. So they were basically two different digits. We cannot combine the two together into one digit. Itni space nahi hoti. There isn't enough space. So what computer scientists did was, they were like, why not give it a nickname? Where I'm not going to come up with writing 10, but I can say that, okay, let's represent 10 as A. Let's represent 11 as B. Let's represent 12 as C. And let's represent 13 as D. Similarly, let's represent 14 as E. And if I have to represent 15, I'm going to do that using F. So what they did was that they sort of cracked that code कि यार okay अगर जगह कम है और इतनी जगह है कि एक ही digit आ सकते हैं या 1 आ सकते हैं या 0 आ सकते हैं, so they were like, okay, let's not try to push this thingy into existence कि एक 1 और 0 को एक ही जगह में डालें. What we are going to try to do is we're going to assign that a specific number. We can say, okay, A could be 10, B could be 11, C could be 12, D could be 13, E could be 14, and F could be 15. And so they expanded this all the way from 0 to 9 and continued this 9 ke baad 10, 11, 12, 13, 14, and 15 journey by calling it A, B, C, D, E, and F, where every letter is corresponding to this table. A is basically having the value of 10, B is having the value of 11, C is having the value of 12, D is having the value of 13, E is having the value of 14, and F is having the value of 15. So now the same slot where either 1 could come up, 0 could come up, or a single letter like A could come up. We can successfully now ensure that this A, because we have sort of coded it at the back end, A ki value to 10 hai. So we can now write 10 in the same slot by not writing it as 10, but rather calling it as an A. And that is where we have the emergence of hexadecimal, because hexadecimal is now that number system which allows you to have 16 different values. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And these 16 different values are sort of used to simplify all these complex sort of binary calculations. Iski uses kya honge? That is something we're going to discuss inshallah in our next few classes. But for now, what our focus is to understand what hexadecimal is. How are we going to be converting? The way we converted from binary to denary, we are also now required to understand how am I able to go from denary to hexadecimal, hexadecimal to denary, and at the same time binary to hexadecimal, and of course hexadecimal to binary. So now that's the discussion of our today's class, where now we understood, okay, we have a third type of values, hexadecimal value. An hexadecimal value could be having a value something like 7A. So now this is a hexadecimal value. Why is this a hexadecimal value? Because it is created from this set. अब इस set के अंदर we see we have 7. That's perfectly fine, right? Similarly, we also have A. So it's a perfect creation from this list. Similarly, when we were discussing the denary part, if I have to create a number like maybe denary. Yeah, so if I have to do something like 786, so I see 7 is also from this list, 8 is also from this list, and luckily 6 is also from this list. So all the values are within the list. Hence 786 is a denary number. Similarly, if I have something like binary 1010, I see 1 is also from the list, 0 is also from the list. So again, this makes it as a perfect set, what do we call it, binary number, because it's from the list of possible values. Similarly, any number which is written in this format is going to be a hexadecimal value. Why? Because it is going to be within this list. Now, if somebody writes something like 7 or rather than 7 @k, is this a hexadecimal value? This is not a hexadecimal. Not a hexadecimal. Why? Because none of these two things, neither @ nor k, is from the list. Not from the list. So now we are going to learn that, okay, if I have a number like 7A, how can I convert this 7A into binary? How can I convert this 7A into denary? And now if I have something like binary or denary, how can I convert that equivalently into your hexadecimal context? So that is something which we are going to be just studying at this point. Now, sort of the first thing we should do is that if we have a specific binary number given us, the very first thing, how do you convert a binary number into hexadecimal? Binary to hexadecimal. So I'm going to teach a very simple method, something which you're going to love, inshallah, and it's going to simplify the whole thing easily, very easy. Now, if for instance, we have some binary number like 0110 1110, this is a binary number given to us, and they ask us to convert this into hexadecimal. Now, the way hexadecimal works is that hexadecimal divides the computer's binary into the smallest possible values, okay? And your computer's smallest possible value is a set of 4 binary digits, which is known as a nibble. Okay, so what your computer, if I ask you, okay, bro, tell me one thing. For example, what's the smallest unit you can think of? So a lot of you might be thinking, okay, sir, the smallest thingy I can think of is a micrometer. Okay, even though usse bhi chote honge, but let's say the smallest you can think of is like a micrometer or like a centimeter, millimeter. Usse chota aapke zehen mein nahi ja raha. Guys, I'm going to take your questions at the end. Okay, easy there. So just like that, when the computer is trying to convert binary into hexadecimal, what they're trying to do up here is that they try to convert the large binary number into smaller groups. And what are those smaller groups? Those are groups of 4. So just remember this one thing, that whenever you're trying to convert the binary number into hexadecimal number, you try to convert the binary number into groups of 4. So let me write this up here. So you convert the binary into groups of 4. Into groups of 4. What do I mean by groups of 4? Okay, groups of 4 would basically mean that you separate 4 digits, then you another separate 4 digits, and you sort of convert them into two different peaks. So we have 1 0 1 1 0 up here, 0 1 1 0 up here, and then we have a separate 1 1 1 0 up here. And now your task is to basically convert each of them separately into its corresponding denary value. For example, if I have to convert this binary into denary, I know that the first position value is 1, this is 2, this is 4, this is 8. No need to continue. Okay, jitne tak hai utne tak hi rahenge. So 1, 2, 4, 8. Similarly, this is also 1, 2, 4, and 8. Now convert this. This is what? 4 plus 2 is 6. I get the first part to be as 6. How did I get it as 6? 4, and this is, we have a 1 up here, so 4 plus 2 is 6. And up here, we have a 1 up here, we have a 1 up here, and we have a 1 up here. So 8 plus 4 is 12. 12 plus 2 is 14. So you might be saying, okay, now let's try to merge them together. So you'll say, okay, sir, my answer is 614. But you know, there is a slight problem. You cannot write 14 as a single digit. We only have the capacity to write a single digit. Ab yahan pe to 14 aa gaya. This is an issue. But because this is an hexadecimal, we know that if I have to write 14, 14 has the shortcut as E. So if something comes up to be as 10 or greater, we are going to write its shortcut up here. For example, this came out to be as 14. So rather than writing it as 14, this logic which we studied up here, 14 is an E. So I'm going to write an E up here. Hence, my final answer, now I'm going to again join the two terms together. So I sort of separated them, found the separate value, and now joined them together using a glue. So this again comes up to be as my final answer, which is 6E. And there you go. We just converted this binary number into a hexadecimal. So this answer up here, which I have this 6E, that's in terms of hexadecimal. So that's how you basically convert a binary number into hexadecimal. Similarly, let's do another question so that you understand this concept even better before moving on. So like example number 2. And example number 2 could be, what if we have something like 1 1 1 0 0 1 0 0. Now to convert this, just like before, you're first going to break it into two groups. So I might break this into one group and this into the other group. And so this comes out to be as 1 1 1 0, and this comes out to be as 0 1 0 0. So this is 1 1 1 0, and this is 0 1 0 0. Now I'm going to convert each of them separately into its denary value. 1 2 4 8. Similarly, 1 2 4 8. So convert them. This is just a 4 because we don't have anything else up here. So the 4 over here. But these are big values, right? 8 plus 4. Perhaps we already did this to be as that. So let's make it a bit different. Okay. So let's keep it as 1 1 0 1. Okay. Let's try to make it a bit different. How do you raise it? So this is 0, this is 1. Okay. So now this is 1 2 4 8. So now if I convert this, 8 plus 4 is 12. 12 plus 1 is 13. So now 13 is represented using a D. So I cannot write 13. Perhaps I'm just going to write a D up there. And similarly, this is a 4 because that's only part where we have 1. Now again, the separated parts are to be joined together with each other. So I see that my final answer comes out to be as D4. And that's how you generally convert from the binary number to a hexadecimal number. So I'm going to open the chat box again. Any questions regarding this, and I would love to answer them before moving on. So the chat box is open. Also, we had 2 questions before kiski hands were raised. So you may just ask those if it's still not clear. Perfect. That's so great to know. Clear ho gaya. Great. Got it. Perfect. Sir, I have 3 questions. Yes, Stargazer bhai pucho. So if we directly make table of hexadecimal. So if you're talking about this table, तो ये तो बनाना है. Abhi guys, just understand the concept. Don't think about these questions in terms of exam mein kya karna hai. Once we do those practice questions, once we are going to solve those exam level questions, wahan pe I'm going to share kya hoga and kya nahi. Sahi hai? So everything will be shared there. So will proper classes be starting from? No. The content covered in the demo classes will not be retaught. But we directly make table of hexadecimal and then convert. वो मुश्किल हो जाएगा. So I'm giving chem and CS and octal. Is it very easy? Very easy. Sir, is it necessary to remember the hexa, binary, and ternary table for conversion? So if you're talking about this specific thingy, this register की values, so yes, ये over time आपको याद ही हो जाएंगे, ये इतने मसला नहीं है. Once we start practicing them, ये आपको आराम से याद हो जाएंगे. Okay, so ये आपको याद हो जाएगी. Sir, P2 कब करवाएंगे? So P2 would be apparently most probably starting from August. So the PDF will be shared. Don't worry. Yeah, so in most probably yes. First, how can we make the table of binary? So I guess you missed out yesterday class. आप कल की class देख लो and उसके बाद आपको अच्छे से याद हो जाएगा. Not this one, the one in the CS2210. Oh यार आप book को छोड़ दो. Book के अंदर जो चीजें, book has a lot of extra stuff, वो आपको याद नहीं करने. Okay, वो आपको याद नहीं करने. The stuff which is there in the book, that is something way extra. Okay, so you're not required to memorize all of that stuff. Okay, yeah, keep that in your mind. And for anybody who might have missed yesterday class, so I would recommend please watch that. सिर्फ तभी आपको समझ आनी कि आज हो क्या रहा है. Otherwise, it won't make sense to you, right? So that's how you convert a binary number into a hexadecimal number. So we saw what's a hexadecimal number. It's a number set, a way of representing numbers where you have 16 different values. We can only represent single digits numbers, but because after 9 we have double digits number like 10, 11, they are no longer single digit. That's a problem. So what computer scientists did was they were like, okay, for the double digit numbers, we can assign a single letter, right? Which is again going to occupy a single space. So we have A, B, C, D, E, F, which is occupying these specific values up here. And likewise, if we move ahead, the first thing which we studied was conversion from binary into hexadecimal, where if you want to convert a specific binary number into hexadecimal number, the way you convert it is that you break it into groups of 4, and then the groups of 4 which you have separately created, you sort of convert each of that into equivalent binary number, and then you join the values later on, and that gets you a final answer. Okay, moving on, the second example was also solved, and now what's an 8-bit? वो बाद में देखेंगे. Guys, don't jump off. Okay, so the content which is being taught only stay relevant to that, because there is stuff which we're going to study, but once you understand a bit of the stuff. Okay, so जब तक आपको चीजें समझ नहीं आएंगी, आप आगे भागोगे तो आपको कोई फायदा नहीं होगा. So just follow the pace, whatever I'm teaching. I know आप लोग में से काफी बबरशेर यहाँ पे बैठे हुए हैं जिन्होंने तीर मारे हुए हैं अपने स्कूल के एग्जाम में. हमें पता है आपने 3 साल CS पढ़ी हुई है, तो chill guys, chill. Okay, it's not necessary that you jump into asking questions which we haven't studied. We're going to cover every single bit of it, but at the end if something is left off, you can of course ask me in great detail. But for now, it's better to stay relevant to what we are discussing. Now we studied the first thing about how you go from binary to hexadecimal. Now let's study the other way around. What if I give you a question where you're expected to go from hexadecimal to binary? You know what, that's also pretty much very easy. So hexadecimal to binary is literally the exact opposite of what we just did. For example, a question is given to you saying that there is a letter like 6A. How are you going to go into binary? So the way we joined them and separated them, the same model is going to be applied up here. So you basically separate the digits and the letters. So we have a 6 being separated up here. We have the A being separated up here. And now we know that A is basically what? From the table which we had up here, the small shortcuts which we had, A is a 10, right? A is a 10. So I know this A has the denary value 10. This is 10. So now I'm going to convert each of these stuff into its corresponding binary. I know the values for the specific positions 1, 2, 4, 8. Similarly, 1, 2, 4, 8. And now if I have to write 6, so 6 is a denary number. If I have to convert it into binary, I'm going to put 1 under which? 4 and 2. And the other 2 are going to be 0. And likewise, if I have to convert this A, because I know A has the value 10, 10 is going to be 8 plus 2. So 8 followed by 2, and the other 2 are going to be 0. And now if I join the 2 together, I get my answer to be as 0, 1, 1, 0, 1, 0, 1, 0. And that's your final answer when you want to convert this hexadecimal into binary. So it's exactly the opposite of what we did. When you're given a hexadecimal number and you're expected to convert it into binary, you take that number, you split the digits, okay, you split the digits, then you take each of those digits separately, convert each of those digits into its corresponding binary, and you join the 2 binaries together. For example, let's do one other example. Okay, so let's do an example where you have something. Let's do a bit of a complex example. Let's say you have a number CD in terms of hexadecimal, and you're expected to convert this into binary. How are you going to do it? So you're going to take this C separately. You're going to take this D separately. Now I know C and D are not denary, so I have to convert them into denary. So C ki denary kya hai? We know that C ki denary is 12 and D ki denary is 13. So I'm going to say that, okay, this is basically 12 and this is basically 13. Now I need to convert each of them into its corresponding binary value. So if I have to convert these numbers, I'm going to do it 1, 2, 4, 8. Why am I only going till 1, 2, 4, 8? Because it's a small number. So small number, if I do something like 16, 32, 64, 128, all of those places are apparently going to have the value 0. So if the value is 0, I can ignore it. Okay, I can sort of ignore it because it holds no importance for me. We are only going to care about the values which are 1. So because the value is small, 13, 14, anything less than 15 can apparently come in these 4 digits, 1, 2, 4, 8. That's why I'm again and again only creating 1, 2, 4, 8. Now, if I sort of have to convert this 13 up here, 13 kaise hoga? 13 would be 8 plus 4, which is 12. 12 plus 1 is 13. That's the first part. Well, how am I going to get to 12? It's going to be 8 plus 4, 12, and the other two are going to be 0. And now I'm going to basically join the two again together to get my final binary, where this would be written on the left hand side. Why? Because C was on the left side, so this binary will be on the left side, 1, 1, 0, 0. And this D is on the right side, so it's going to come up on the right side, 1, 1, 0, 1. And that's your binary for CD. So we just saw how you may go all the way from the binary to the hexadecimal part, and similarly hexadecimal to binary, which sort of was the main challenge up here, right? Going from binary to hexadecimal and hexadecimal to binary. But at the same time, we also know, kyunki humne ye to dekh liya, if I have to shade this diagram which I was creating, how I'm going to go from this way to this path, that's perfectly fine. And now I'm going to go from this path to this. But we are yet to see how am I going to go from a direct denary number into a hexadecimal number, and similarly a hexadecimal number into a denary number. Now, if you open up the harder education book, which is usually being taught in the schools, I hate that. Okay, that book is pretty much very useless. You know why? It has complex calculations, it has useless methods which are correct and work perfectly fine but have a large chance of errors, and of course it has extra information. Throughout this course, I'm going to be teaching you what things to think about, what things to focus upon. If there is something which you need to ignore in that book, what it is, and what are the parts which you need to focus upon. Okay, and for that reason, I'm not going to be sharing the method with you which is in the book. I'm going to be sharing a method which is way more easier, way more simpler, and is 100% approved by your examiner, because I myself made use of that method not only in my O levels and IGCSEs, but also in my AS level and in my A2 level, which means that it's perfectly fine. Okay, if I got a distinction, that means it's perfectly fine. So what's that method? So if a question gives you a denary number, okay, if a denary number is provided to you and you're asked to go into the hexadecimal number value, the best and the easiest approach is that rather than directly jumping into hexadecimal, you go from denary to first binary, and then you go from binary to hexadecimal. You add an extra step. There is one other direct way too, but that direct way involves division with 16. And division with 16 without a calculator is very challenging. And 90% of the students up here will end up making some sort of mistake, which means that you're going to lose upon easy marks. So there is no need to rush it up. In your exam, you're going to have 1 hour 45 minutes, which are more than enough to do everything, even recheck it twice. We need to go with the method which ensures that you don't lose upon your marks. And how will I going to convert this? So let's take an example. Let's say I have a value something like 77. So first and foremost thing would be converting this 77 into binary, and then converting that equivalent binary into hexadecimal. So if I have to convert 77 into binary, how will I do it? So I'm going to make those values. So I know that the values are always going to be 1, 2, 4, 8, 16, 32, 64, 128. Anything greater than 15 will require 8 bits. Okay, what are 8 bits? So all of these slots which you see, these positions are known as a bit. Okay, so every box is equal to 1 bit. So I say this one box is equal to 1 bit. If I only count the first 2 boxes, that would be 2 bits. If I count the first 3 boxes, that's 3 bits. And similarly, 1, 2, 3, 4, 5, 6, 7, 8. These are 8 boxes, so we call it a 8-bit register. Why? We say that, okay, it's a register which is going to be storing binary values, and it can have 8 bits, which means 8 different binary values. So a bit is the smallest value your computer can store. And we know what's the smallest value your computer can store. It could either be a 1 or a 0. On and off. That's the smallest and the most simplest thing which our computer can process. So the computer scientist said that, okay, if I have to summarize that the smallest thingy that ever exists in our computer science is a 1 and a 0, let's call that a bit. So that one small digit, a 1 or a 0, is known as a bit. So when I say that something is an 8-bit register, the 8-bit register basically means that it is a type of box, a shelf like this, which has 8 boxes inside it. If I say that there is a 4-bit register, this means that, okay, we have a box like this, but it only has 4 boxes. What will be those 4 boxes? The first 4 boxes. So 1, 2, 3, 4. So this would be a 4-bit register. The larger one was a 8-bit register. Similarly, you might have 16-bit register, but in your exam, the most of the times you'll be only defined to work with 8-bit registers. Okay, so now what we're going to do is that whenever I have a value greater than 15, in most of the cases, we need to create 8-bit values, which means that going up to 128. Now, if I have to write 77 up here, how will I do that? Pretty much easy. I'm going to put 1 under all those places, which when I add them up, I should be getting a 77. How? 64 plus what? So 64 plus 10 is a 74. 74 plus 3 is 77. So I need to put 1 so that I get 13. How will I get a 13? 8 plus 4 is 12. 12 plus 1 is 13. So I get this to be as my binary values, which means all the other places have to be ignored. So if I have to ignore something, I'm going to put what? I'm going to put zeros. So 0, 0, 0, 0, and up here. That's my binary. So now I got the second intermediate answer. And now this simplifies my method, because right now I'm exactly at this stage. I have the binary and I need to convert this into hexadecimal now. So if I have to convert this into hexadecimal, what did we study? We studied that you break it into groups of 4. So I'm going to convert this into a group of 4. Okay, by the way, red, let's do it as green. So I'm going to convert this into groups of 4 and then this into group of 4. And now if I separate them a bit, I can write this to be separately 0, 1, 0, 0. And I can write this separately as 1, 1, 0, 1. And now I'm going to convert each of them separately back into denary. But this time, if a value exceeds 9 and it's 10, 11, we're going to convert it into letters. So let's do it. This is 4. So here the direct 4 hi aa gaya. What is this? It is 8 plus 4, 12. 12 plus 1, 13. But I cannot write 13. So I'm going to go back up here. Perhaps let me rewrite it up here. I know that A is always going to be 10. B is going to be 11. C is going to be 12. D is going to be 13. E is going to be 14. And F is going to be 15. So now when I know that this is going to get me 8 plus 4 as 12, 12 plus 1 as 13. 13 is a E. 13 is a E. So I'm just going to write E up here. And right now I'm going to join the two together and I get my final answer as 4E. So that's how you convert a number from denary to hexadecimal. Now, if I have to give you, even explain this to you and verify this to you, let's search for online denary to hexadecimal converter. And let's try to do it up there to see if कोई गलती शलती तो हमसे नहीं होगी. Okay, so let me start my screen sharing. Denary to hexadecimal. Okay, so you'll be able to see the screen. We have this decimal to hexadecimal. So decimal is basically denary. Okay, but in your course it's generally known as denary. So we had the denary number as 77, right? Yeah, 77. So now if I convert it up, you can clearly see my hex number comes out to be as 4D, which is 100% similar to that which I had on the screen up here through my calculations, which explains 100% how I got the answer to be as 8 plus 4, 12, 12 plus 1, 13. Okay, 13 is a D, my bad. 13 is a D. Okay, that's great. Verify over here. So that's the reason why you always have to recheck the work, because there's a great chance you might make a mistake. So this was a 13, so 13 is a D. Sorry, my bad. It was in an E. And that's how you convert a denary number to a hexadecimal number. Now, if a question asks you to convert a hexadecimal number to a denary number, it's best that you convert that hexadecimal number into binary number first. And definitely we all know how to convert a binary number into denary. So then you convert that binary number back into denary. That is the whole concept for today. And that's everything you need to understand in regards of binary, denary, and hexadecimal. Okay, in our next class, inshallah, for the students who register with us, we're going to do some exam style questions. We're going to look on to how we need to further jump into this content. But that officially marks the end of our demo classes, where we have studied everything from denary, binary, and hexadecimals. And now I'm going to open up the chat box for any sort of question which might not be clear or you might want to ask. So again, no need to repeat the message. Okay, I'm going to see it. If anybody is repeating, I might not answer that and I might remove the student. So just send the message once. I'm going to come to it. Okay, easy scene. So you can just send the message, and I hope this is clear now. So which book should we buy? Book doesn't matter, to be honest, much, but if you want to go harder education wali book use karo, but I'm going to explain what to study from it and what not. That's so great to know. That's so great to know. So what if the number is below 10 in hexadecimal? If it's below 10, then you're going to write it like the normal 10. You see this 4. So we wrote it like the same 4. Yeah, below 10, so we wrote it as 4. So if something is below 10, we write it like this normal number. But if it's greater than 10, it's going to be like A, B, C, D, E, F. When is the next class? Inshallah, next class is only going to be for the registered students. It's going to be from the next Monday. So are there holidays till 8 June? Yes, you may assume them to be holidays till 8 June. In the meantime, you can also sort of take the other demo classes because it's not like holidays, but right now we are giving you the chance to take demo classes from the other teachers. Proper classes from the 8th of June. Yes, sir. Inshallah, 8th of June, that you all would be added into your groups. I'm going to create a different portal. I'm going to add you all onto that. Sara verify ho jayega. I'm going to save your all numbers so that if you guys are messaging with me with any queries or problems, to main sab kuch aapko one-on-one foreign explain kar sakun. When will there be a real class? This isn't a demo class, by the way. This is sort of a real class and access. Okay. So yeah, ye cheezein pe nahi padhai jayenge in the real class. How long will it take to complete the full syllabus? So the goal is to complete everything by the 10th of September, inshallah. 10th or 15th you would be done with the practice plus the syllabus, which would leave you with at least 15 to 20 or perhaps 25 to 30 days for your exam side practice. So our past papers 25 din color, which would be more than enough. When will the syllabus end? Again, you may assume it to be ended around 10th of September, inshallah. Sir, in P2, will you teach us pseudocode? Oh, there is no programming required. Okay, so you're not required to learn any programming language. You're going to be learning pseudocode on it. How long will the classes continue for? So it's going to go all the way till November, inshallah. So should we make notes side by side? Not at all. I'm going to share this PDF on your portal afterwards. So आप बस वहाँ से बाद में notes बना लियो, clear हो. Class के दौरान just focus on the class what we are learning. Okay. What grade did I get in my exam? I got an A star with a top in Pakistan distinction in IGCSE computer science. So back in 2023, I scored the highest in the country, mashallah. Will you provide topicals and past papers, or should we buy it? So I'm going to provide you with topicals. So I don't think so you need to get topicals because they are available onge. As for the past papers, if you want to purchase past papers later on, you might do it afterwards. But abhi koi zarurat nahi hai. Is there a class one? Not at all. And then koi nahi, if you understood how we got a 4D right now, that is what matters. Agar nahi samajh aayi to bata do, main phir se samjha dunga. So I don't know anything about P2. So of course, I'm assuming कि आप में से किसी को कुछ भी नहीं पता. Like आप लोगों ने कभी CS पढ़ी ही नहीं है. So you're seeing this concept which I'm literally teaching at this point, on which we took 2 hours of classes. That is something which I have to teach in A levels, where I may assume कि बच्चे को पता है ये 15 मिनट की कहानी होती है, maximum 30 to 45 minutes. The reason why I'm spreading it up is to ensure कि if anybody has never studied anything, उसको भी fully समझ आए. Okay. So could you clear that there would be days off? Yes, off here. Classes are 5 days a week for computer science. For the other subjects, they might be 4, but for CS, it's going to be 5 days. Sir, आप पूरा syllabus कैसे cover करेंगे? जैसे हमने अभी बिस्मिल्लाह की हुई है, तो इसी तरह कवर हो जाएगा. वी हैव बीन डूइंग इट फॉर द पास्ट फ्यू सेशंस. ओके, सो ये आप स्कूल्स में आपको ये आप खुद देख लोगे, स्कूल में आपके 3 सालों में कराया गया है ना. सो यहाँ पे 4 महीनों का कोर्स है ब्रो, सीरियसली 4 महीनों का कोर्स है. Stargazer, I hope you don't want yourself to be blocked from the class by repeating again and again. Sir, will we have a class this time every day? Yes, inshallah. You need to code physically on a computer? No, no, no. Are these classes for October, November batch? Yes, they are for October, November batches. And for any student who might want to have, an early jump for the May June classes, because I know you guys are going to have your mock exams in December. So any student who wants to prepare for the mock exams beforehand, aapke liye good scene, a lot of students have been reaching out to. Once you register, you're going to be having the recordings till the 1st of January. So till the 1st of January, you're going to have all the recordings. So once you are done with the course, आप उसके बाद एक दफा recordings फिर देख लेना for your mock exams, and inshallah once you are done with watching the recording twice, from the 1st of January, the only thing you should be doing is practice. The more you practice, the better your chances for getting an A star and a distinction, inshallah. So if I've already learned Python from, can I use it for the optional part in P2? I would not recommend that, क्योंकि फिर आपको pseudocode अलग सीखनी होगी and आपको Python अलग practice करनी होगी, तो mess up हो जाता है. Python will help you. I also had learned Python before my IGCSE exam. तो आपको वैसे generally आपके thinking में फायदा दे देगा, but don't use Python. Okay, are these classes for IGCSE? They are 100% for both IGCSE and O levels. कोई फर्क नहीं है. Okay. So Sep तक सारा complete हो जाएगा, mid of September तक सारा हो जाएगा इंशाल्लाह. Is this class recorded? Yes, it is. Can you explain in Urdu and English? Sorry, Usman, that might not be possible because we also sometimes have international students with us, right? So it's not fair to them. We have Urdu and like English mix, so we have to go with English. So the classes which you took previously and this one, are they all recorded? Yes, all of them are recorded. So past paper quiz, will we do it, and by which one will we do? So past paper practice is something जो कि आप लोगों ने खुद करनी, okay? I'm going to share the plan with you. The plan, I even shared it with a student that day. The way we're going to do it for the October, November students is that inshallah by the end of July, okay, so your June and July, that's going to be spent covering the paper number 1 course. Okay, so by the 1st of August, you'll be done with paper number 1. You're going to just do a quick revision. And then from 1st August onwards, you're going to solve one paper every 2 or 3 days. So you should be solving ideally 2 to 3 papers on your own. Any question which you don't get, any concept which you are unable to recall, you're just going to ask me and I'm going to explain it to you. Okay, so you're going to start practicing your exam paper number 1 from the 1st of August because आपका course P1 का हो चुका होगा. Alongside this, I'm going to give you 4 fully solved and explained P1's videos from our past paper session so that you understand how to attempt a paper 1, what mistakes to avoid, what to look after, and all that stuff. And at the same time, you're going to start learning paper number 2. Now, your paper number 2 will be done by 15th of September, which means that 15th of September तक आपकी P2 plus programming की initial practice would be done in the classes. But by then your P1 would be 100% done. Now your exams for paper number 2 are going to be towards 20th of October, which would leave you then with one entire month, 15th to 20. I haven't seen the timetable though, but it's going to be in between that frame. But then that leaves you with 1 month for full practice for P2. But once you get to this practice, आपकी P1 इतनी strong हो चुकी होगी कि आपको P1 का मसला नहीं होगा. You would be already scoring 70 plus there, and then you're going to fully grind for paper 2, and you're inshallah in 1 month get to 70 plus there too. So you're fully good to go for an A star. We need to memorize stuff, the stuff which is important, and उसको हम पहले conceptually समझेंगे, and then you're going to, sort of memorize it. But memorization से ज़्यादा what matters is your understanding. If you understand something, easily हो जाता है. Will you do the registration? So no, we will not be doing the registrations. वो आप लोग को खुद ही private या अपने school के through करानी होगी. Are we done with chapter number 1? No. We are just done with like a small chunk of chapter number 1. Will there be classes for the May-June batch? Yes, there will be classes for the May-June batch, which will be started after the October-November session ends, inshallah. But उसके अंदर मसला ये होगा कि आप फिर कोर्स ही जाके मार्च में एंड करेंगे तो फिर आपको प्रैक्टिस का टाइम कम मिलेगा. अगर आप अभी से कर लेते हो फिर आपके पास प्रैक्टिस का अच्छा खासा टाइम मिलता है. आप जनवरी ऑनवर्ड्स, you do practice 5 months, so very much good to go. See. सर बड़े मई जून 27 तक सारा भूल गया. शाफे भाई आप नहीं भूलोगे ना. That's the whole game. Why will you forget it? You won't be forgetting it because आपने एक दफा खुद कवर करने हैं, एक दफा आप रिकॉर्डिंग्स खुद देखोगे बाद में, and then by 1st January onwards आप पेपर्स करते जाओगे रोजाना या at least twice a week, you're going to do paper number 1, twice a week, you're going to do paper number 2. And if you keep on doing it, inshallah ta'ala, you can easily back that A star. Koi masla hona hi nahi hai. So if I'm giving May, June 28, of course, that's perfectly fine if you want to get that head start. By the way, this course will ensure that you're done with the whole course by October. Okay, so yeah. So when is this CSCI usually? We will check. I can check that timetable for you all, but it's going to be around that plan. So I hope, and I'm glad you love the plan, right? So if you follow this plan of mine, I can assure you, inshallah, easy A star wali game, inshallah. Given that you take live classes, you listen to what I say, you do all our assignments, and you follow the plan. A lot of students, they are like, okay, online, they don't follow the plan. If you miss upon this plan, I will not assure you an A star. If you follow this plan, you take the live classes, you do everything the right way, inshallah, with the help of Allah, aapka A star aa jayega. So can we practice other boards paper? No, not required at all. You have a lot of IGCSE and O-level papers available beforehand. So usme jaane ki zarurat nahi hai. There is a big chunk of difference in the syllabus content. So according to you, kitna time lagega for hame? Around September ke mid tak aap kar loge. So yeah, you see, so you have like 20th October ka aapka P2A, which makes my plan perfectly fine. You have 1 month and sort of 5 days for paper number 2 ki practice bhi. So you do have a large chunk of time for practicing. You have a good amount of time for classes. And of course, iske dauran, you know what? Sometimes I have this bad habit that I also take extra classes. So we might have an extra class over some weekend. Up to me if I want to take that. So main wo bhi kar sakta hu, and I might, sort of have an extra class being conducted just for the purpose of extra practice, because I want to ensure that every single one of you gets that A star, inshallah. So I'm a private candidate and I don't know how to register. You may just search on YouTube how to register privately. To wo aapka kar lenge. Otherwise, I don't know, Conceptuals Academy to nahi karti, because we are not officially registered with Cambridge in terms of like as an exam center ki jo bachcho ki admission bhijwaye. But yeah, you may just search on Google or maybe watch a YouTube video. Ask your parents to watch a YouTube video on how to register for private exams for IGCSE level. Both easy सीने आराम से हो जाते हैं. Any other questions? Do you know the dates of registering? Again, I'm not sure though, but you may just search up for October, November registration deadline and aa jate sab. सर अगर हमें कुछ समझ ना आए तो फिर क्या आप सारा कोर्स पढ़ाने के बाद एक क्लास क्वेश्चंस के लिए रखेंगे? तो आपको क्यों कुछ समझ नहीं आएगा जब आपको हर क्लास के बाद मौका दिया जाएगा अगेन एंड अगेन टू आस्क योर क्वेश्चंस? तो आपको जो चीज समझ नहीं आएगी आप मुझसे उस वक्त भी पूछ सकते हैं. आपको मेरा व्हाट्सएप नंबर भी दे दिया जाएगा, आप वहां भी पूछ सकते हैं मुझसे. एंड ऑफ कोर्स जब हमारा क्वेश्चंस उसके बाद प्रैक्टिस हो रही होगी उस वक्त भी पूछ रहे होंगे. बट ड्यूरिंग द क्लास कंटेंट आई एक्सपेक्ट यू ऑल टू आस्क क्वेश्चंस. जहां पे कोई चीज समझ नहीं आ रही तो आप बोलो सर मुझे ये चीज समझ नहीं आई, ताकि मैं आपको उसी लिहाज से बता सकूं कि आपको ये चीज समझ नहीं आई तो ये समझ लो. No, of course you're free to leave. You're of course free to leave, but that's it. And there would be a group for asking questions, right? Yeah, of course. So when you register, there would be, let me explain the whole model. So you register with us, you get access to a group which has the registered students. Okay, so mashallah, alhamdulillah, we have a large chunk of students who have already registered. Okay, so you're going to have a very good community. Abhi se. Okay, you're going to have a very good community. Abhi se, we're going to be registered. Aap ek us group mein hoge. And then there is one community group of ours which has like thousands of members. Okay, it's going to be free and open for all. You're going to add all of your friends. So like the one which we have right now for the O-level one. So if I share the O-level one, like the one jo ki abhi exam de rahe, this one, you see, CSIT, CSE O-level, the one which we have right now, that one has over 1,000 members, mashallah. So it has like around 1,500 people in that. And you can ask as many questions as you want. I respond to them too. But the thing is, aap questions udhar pucho, and at the same time, the best thing is group mein pucho, but reach out to me. Okay, I'm going to be available to you. I know a student that day reached this concern, sir, teachers jawab nahi de rahe. I'm not like that normal teacher of yours who's like, okay, मैं कोई आपको 2-3 दिन बाद जवाब दूंगा. You message me and I'm going to try my best to respond as fast as possible. Okay, I usually respond within a few hours or even less than that. So try to ask a question directly for me so that you don't get misguided. Okay, and of course, then you would have a community group for asking questions from your peers too, and you would have a good community. Okay, maza aayega, don't worry, it's going to be fun. We make this whole course very, fun oriented. Sir, has anyone told you you look like Hassan Rahim? Kya baat hai bhai? क्या बात है। कल पता नहीं उस दिन मुझे कोई बोला था करण औजला, आज हसन रहीम, कल पता नहीं कुछ और ना बोल दे, अल्लाह खैर करे। How much is the fee? So you may reach out to Ma'am Naiba, वो आपको सारे बता देंगे details. If you are interested in joining the computer science program or maybe any other classes, क्योंकि if you are opting for other subjects too, then you are eligible for a discounted rate. Okay, so this is Miss Naiba number. She is our TA who is managing all the registrations and all. So just text her. If you have already messaged her, she might respond very quickly, inshallah. But अगर नहीं किया तो इट्स बिकॉज अ लॉट ऑफ स्टूडेंट्स हैव बीन मैसेजिंग, तो मैसेज आगे पीछे चल जाता है, तो बस डीएम ड्रॉप कर देना, गुड सीन हो जाएगा। सर तलविंदर और हसन रहीम, क्या बात है यार, हसन रहीम स्वेर ऑन वल्लाही क्या। और करण कौशला वाली बात, ये मुझे लिटरली किसने बोला था, आई रिमेंबर, आई एम नॉट श्योर किसने किया था, बट यस बोला था। But that is it for today, everybody. That marks the end of our demo classes. Alhamdulillah, it was a lovely set of classes with you all, and I hope you guys got to learn a bit and that you found it to be good. And I expect every single one of you to be in our registered classes, inshallah. Contact Miss Naiba. The recording would be available. If you have any other questions, if you have any other question regarding the course, if you are still wondering कि नहीं जाना चाहिए हमारे साथ, कोई और गिले शिकवे हो, या फिर भी आपको समझ नहीं आ रही, so that's my private number 312-527-0760. Just text me, don't call me. I'm bad with picking up calls though. But yeah, just text me on my WhatsApp number and I'm going to get back to you on it. Okay. All right, everybody. That is it for today. Take care, everyone. See you guys, inshallah, in official register classes next week. Allah Hafiz.